All right, I'm back with another video. I kind of want to share something with you guys real quick though. Um, so I don't sit at my computer all day, all the time. I may sit at it for 15 minutes or a half hour, get up and then stretch my legs. I may sit at it for a little longer than that. I like to stand up, stretch my legs, move around a little bit, clean the house, kind of get the juices or blood flowing or whatnot. But sometimes when I stand up and move around and do other things and stuff, it kind of gives me a chance to think about things. And most of the time when that happens, I start getting really creative with my thoughts. Um, for example, this next part that we're going to after the section we're on right now, which I'll go ahead and transfer this over here so you can see what I'm talking about here. So we left off with inherent access. In the last couple of videos we've talked about derived classes, multi-level inheritance, multiple inheritance for a single derived class. Now we're going to get into inheritance access, which if you're not familiar with it, on the right side we got W3 schools, on the left side we got VS Code, which is a text editor. But I so happen to look at the next section right here that we're going to go to after this section here, which is polymorphism. And when I stood up and walked away for a minute, I kind of had some thoughts, especially on that particular word, which I'm saying it now because if I wait until later to say it and stuff, then I'll probably forget about it. But I've played quite a few games. In fact, there's still one game I do kind of play and stuff when I need a break from other things or just something to enjoy with other friends or whatnot. It's called Hearthstone. I'm sure many other people have played it. I specifically like the Battlegrounds area of it more than anything else. But I also used to play World of Warcraft, the regular Hearthstone, and a number of other games. And the polymorphism that is in the next, that will be probably part of the next video I make, is something I was thinking about. Polymorphism. I don't know exactly what it means for C++ yet. I've probably read about it once already, but I've probably also, I know I've gotten quite a bit of it already. But in the game World of Warcraft, when I used to play it, if you played as a mage, you had this skill ability where you were able to polymorph an enemy into a sheep. Um, I'm pretty sure it probably doesn't mean that in this case, but I got to thinking, in World of Warcraft you can do that. In Hearthstone you can do that. You can take one card, play it, and change another card into something else. There's actually a lot of hero collector games that may or may not have that ability in them, or even open world concept games that may or may not have that ability in it. And I was sitting there thinking, you know what, in Battlegrounds, that would be a complete game changer. What if you could put a card on the field that would randomly take, say, the highest attack character of the opponent and transform their card into something else? It could be another card of your choosing. Maybe you have two options you can pick from, pick one or pick two. Or it could just be random as to what it picks. Or you could pick the card before the battle even starts. That way, when that card goes to play, if it doesn't get destroyed right away, it changes that card into something else. Maybe you want to protect yourself from venom, so you choose to change a card that's got venom on it to something else. And I was sitting there, I was getting really creative with this in my head. So what if I took it and stuff, took a venom card or a Leroy Jenkins card in Hearthstone and transformed it into a cat that did some animation and stuff, and instead of it acting as a card that could attack on the battlefield, it turned into a cat, and it turned around and got mad at its owner and scratched the eyes out of its owner and took one damage out of its owner, sort of thing right there. So yes, I have a very wild imagination that can really make me come up with some really unique stuff, which is why I'm learning all this in the first place, so I can use that imagination to create stuff like that. But since I don't know enough about C++ yet to create those sort of things, I'm learning about it so that I can create those sort of things. Right now, it's just a picture in my head, Hopefully, maybe eventually it'll become more of something I can create. But anyways, getting off topic there. Sorry about that. Let's continue where we left off with C++ inheritance access. Um, in my last video and stuff, I know I kind of took a guess as to what this is, but let's go ahead and get into this so we know for certain. No assumptions, no guessing. So access specifiers. You've learned from the access specifier chapter that there are three specific specifiers available in C++. Until now, we have only used public members of class to access. Members of a class are accessible from outside the class, and private members can only be accessed within the class. The third specifier is protected, is similar to private, but it can only be accessed in inheritant classes, if I said that right. um, so we got the public areas of these right here, which can be accessed from outside this class right here. In this case and stuff, we are allowing this class right here to have access to the public section through inheritance right here, which is what these two sections are. This is the example from our previous video. So now we're going to learn, I guess, a little bit more about inheriting stuff for the private and public sectors, or private and protected sectors. So we got an example here, so let's get this example put into our code. I'm trying to look here and see how much this we're going to actually keep. So it doesn't look like we're going to keep the other derived class. So let's go ahead and get rid of that one there. We got the base class, which we're going to go ahead and rename it to employee. We're going to change the public from public to protected. First time I think we're using this, but I'm not sure. I don't remember. We got a comment after that. So let's go ahead and add that comment in there. Protected access specifier. And we're going to get rid of the function right here and change it to integer salary, which we've used this before. In this case, it may not be the same thing, but we'll find out. We got a comma right here, so we're going to keep that right there, but we're going to change all this. So this class right here is going to be programmer. And it's going to have an inheritance of public and employee. So anything that the employee class has in the public sector, the derived class here, programmer, is going to have access to. And we can go ahead and get rid of this comment right here because looks like we're actually going to have some code here for this time. This right here is going to be public, and we're going to set integer with a variable bonus. Just declare that and then have a void function set salary with a parameter of integer type s. Some curly brackets here, so salary is going to be set to s, and it's just going to be declared right there. And then we're going to move down and create another function. It looks like, yep, an integer type function. I'm going to put another space in between there. There you go. I'm going to create another function. This one's going to be an integer type function. Set salary with an empty parameter. Curly brackets, it's going to return salary. that'll be the end of that right there. And then we're going to move on to our main, and we're going to get rid of all this because we're changing all this. Start with the programmer class and giving it an object. Then we're going to use that object to access set salary and put in an argument of 50,000. And then we're going to use the object again to access bonus and set that to 15,000. And then we're going to output some content here, salary. And you use the object dot get salary with a new line afterwards. Then we're going to output again with some content bonus. My object again dot bonus with the new line after that. Now it looks to be about all of it. I'm going to go ahead and put a space here and a space here, or a new line there. So we're creating an object for programmer, which is the derived class, going to access my salary from with the object from the base class. Now, and then create a value for both. We're going to access this one right here. Let's see. Oh no, we're going to access the function in programmer, which is going to have access to the protected. So like it says up here, the third specifier is similar to private, but can only be accessed in the inherited class. So this being the inherited class, since it has access to public, it also has access to protected. So not fully understanding the access specifiers yet, but the protected can be accessed from a derived class as long as it has inherited the derived class, or the base class, sorry. And so the object is calling the function, which has access to salary from the base class, and it's going to set the variable in the function to 50,000, which then salary is going to be set to 50,000. And then we're going to output that with this line right here, line of code. And then again, we're going to use the object to get access to bonus, which is set in the derived class, and give that a value of 15,000. The question is, so this sets it, this returns it. So when we call this right here, we're setting it to this, but it's going to run through the rest of this code right here. So it's probably going to ignore this part right here. It knows it exists because it's declared, but it's going to run through this code. It declares this, it runs through this, sets 50,000 for that, then comes down here to this line of code or this function right here and returns salary. So that way when it's called down here, it's going to end up returning no. Yes. Okay, no. So we're setting the value of salary right here with this call. and then we're going to get a return of that salary right here with this one because it's going to call the function out of that one. Okay, so that's making more sense. I mean, there's just one letter difference, set and get. Set being right here, which is accessing this function up here, get, which is accessing this function right here to input whatever the salary is right there, which is a return value. And then the next one down is, so since we set bonus for the derived class, we are simply just accessing that bonus right here and outputting the bonus. So our output will be salary 50,000, bonus 15,000. So yeah. Again, there's a puzzle in my head and stuff, and it's just slowly coming together. I'm just slowly starting to understand it. It's not something when I'm looking at this, if I was to look at 2 plus 2, I automatically, boom, I don't have, there's no thinking. The puzzle's already put together. It comes together in less than a second. In this case and stuff, it's taking me a little bit to put this all together in my head because I'm actually having to put the pieces together and follow what the compiler would do to try to decipher this code. Anyways, let's go ahead and save this real quick, run it, and make sure we get salary 50,000 and bonus 15,000. Yes, we do. All right, moving on. Okay, well, that's the end of that. Not a whole lot of examples on that. Not a lot of explaining in there for that. This right here, we kind of had to decipher ourselves. It did have some wording in there, but still, deciphering itself and stuff for me helps me to understand it. Since I'm only doing it once, it's probably not going to stick to memory, but you know what? If this is the second time I'm seeing it, maybe it'll stick a little better this time around than previous time. So, moving on to our next section right here, which is the polymorphism, which was something I was talking about at the beginning of this video right here. Which we will pick up with this right here in our next video. But again, yeah, when I stood up and had walked away from my computer for a second to stretch my legs and whatnot, yeah, that's the thought that I had. I think that could be used for a bunch of different things. If you are playing a hero collector game where it's a turn-based hero collector game, and you had a character that was able to polymorph something, and it polymorphed a one of the other characters that could do multi-shot or buff up the other characters or something like that. So for 2 or 3 turns or whatever and stuff, that character is turned into mud or sheep or whatever. Um, in a sense and stuff, when I used to play World of Warcraft, we would call that crowd control. I'm sure people are familiar with that term, crowd control. Um, it's basically where you can control specific enemies in a game. There's even in real life, there's a such thing as crowd control. It doesn't really mean exactly the same thing, I guess. Um, but yeah. So in our next video and stuff, we'll cover polymorphism and find out what it really is for C++ and try to keep the thoughts in my head separate from what this actually means because it probably doesn't mean anywhere near the same, but we'll find out later. All right, that'll be it for this video. If you like the videos, click the like button. Um, if there's something I said, like normal, that is incorrect, feel free to leave it in the comments as to the correction of something I said. If you have any questions or comments, you can leave those in the comments as well. Eventually, I might start doing, it'll probably be a while, live video. It probably won't be going through so much of this discovery. Right now, it'll probably be more like on topics on me just asking people, uh, working on exercises and stuff and asking people about code or whatnot. But that's going to be a long ways off. It's just a thought in my head right now. And when I mean a long ways off, so it'll be after we get through all this right here, plus probably most, if not all, of the source material from my other source that I'm using to learn C++. So, but that'll be it for this video, and I will catch you in the next video.